Okay, this is the third example of transformation of function. We are now given y equal absolute value of x, and we are supposed to complete these four transformations. So using the order of operation to do the order of transformation, we're going to start out with capital P, which stands for parentheses. But our parentheses in this case is the absolute value. So I'm going to set it up first, like that. So inside the parentheses, according to the general formula for transformation of function, inside the parentheses or inside a function, we have horizontal translation either to the left or to the right, and then we have horizontal shrink or stretch, either by plus b or minus b. So let's see, we have opened outward by a factor of 3, we have shifted upward by 5 units, we have reflected about the x-axis, and vertically stretched by a factor of 4. So immediately we can tell that inside the absolute value, we are going to have to first take care of open outward by a factor of 3, because open outward is another way of saying horizontally stretch by a factor of 3. Now, recall that when we stretch a function horizontally, the number represented by the letter b has to be between 0 and 1. Well, in this case, it is being stretched horizontally by a factor of 3, so we are going to have 1 over 3 right here, multiplied by the x. And since we are not translating left or right, inside the absolute value will just be 1 over 3 times x, just like that. So that PEMDAS done. So this is done. Now the next order operation is exponent. Well, we don't have to worry much about this because we only have absolute value. The next order of operation is multiplication. We already did the multiplication inside the absolute value, which is multiplication by 1 over 3 of the x. But now we also have to multiply it by 4 and thus negative sign as well. So we basically have to multiply by negative 4 on the front. And the reason why we have to do that is because we multiply by 4 to stretch the function vertically by the factor of 4, and we also have to multiply by the negative side because we are also reflecting the function about the x-axis. So these two transformations are now done. And lastly, we have shifted upward by 5 units. Well, we don't have any division, so we can forget that. Addition, which is going with shifting up by 5 units. So we take this whole thing and we add 5 to it. And we don't have any subtraction, meaning we don't have any translating downward. So we are done with this function. So this function is f of x equal to negative 4 times absolute value of 1 over 3 times x, and then all adding 5. So how do we graph it out? Well, we graph it out starting with the parent function absolute value of x. So recall that the graph of absolute value function looks like a letter V like that. So this is absolute value of x. The next transformation is horizontally open outward or horizontally stretched by a factor of 3. So if it's stretched vertically, just like a rubber band, it's going to widen up. So probably it's going to look something like this. So this is absolute value of 1 over 3 times x. Now the next transformation is vertically stretched by a factor of 4 and reflecting vertically about the x-axis. So if it's stretched by a factor of 4, it's probably going to look thinner like this. Hopefully not too thin like that. No, just my bad drawing. So this is 4 multiplied by 1 over 3 times x. And then from here reflected across the x-axis. So like that. And this is negative 4 times 1 over 3 times absolute value of 1 over 3 times x. And lastly, we translate it up by 5 units. So from here, from this one, we'll translate up to here, let's say. So it's gonna look something like that. So this is -4 multiplied by 1/3 times x inside the parentheses, and then plus 5 overall. And yeah, that's how we graph it, you guys.